Hello friends, welcome to Quick Learn website, and I am very excited to inform you that in Quick Learn I have recently launched my website, that is www.quick-learn.in. This website is especially for all the engineering and diploma students and those students who will preparing for competitive exams. So in the blog section of the website, you can find the notes of all the electrical and electronic subjects, just like basic electronics, microcontroller, microprocessor, power electronics, and slowly I will add more notes in the website. And if you are preparing for any government competitive exams, then check also my MCQ series, that is multiple choice question series, and previous year question papers. That will help you in your competitive exams. Here I also upload the quiz test or mock test for ONGC, UPPCL, or for different type of competitive exam previous year question papers. Or for latest update, please join my Telegram channel. The link of my Telegram channel I will give in my description box. So stay continue and keep watching and keep visiting my website. Hello friends, welcome to Quick Learn tutorial series. In this video, I will explain you parallel inverter, its working and waveform. This is lecture number 39 of Power Electronic series. So let's start with the topic. Here we see this is the circuit diagram of parallel inverter. So in this circuit diagram, here we use two thyristor T1 or T2. These two thyristor are work as a power semiconductor switching device. Now come at the source side. We know that the source of inverter is a DC power supply. So Vs is the DC voltage. Now come at the load side. At the load side, here we use a transformer. This is the primary winding of transformer and this is the secondary winding of transformer. When we see this primary winding of transformer, due to this primary winding, we can say that this is a center taped transformer, because the primary winding of transformer is center taped here. Due to this center taping, the primary winding of transformer is divided into two equal halves. AO is the upper part of the primary winding and OB is the lower part of primary winding. Now, we know that transformer is work on the principle of mutual inductance. When voltage and current following in the primary winding, magnetic flux generate. Equal magnetic flux generate in the upper part of the primary winding and equal magnetic flux generate in the lower part of the primary winding and also in the secondary winding. That will induce EMF, equal EMF in the upper part, lower part and the secondary winding. So, if current flow across the coil, if Vs voltage induced in the upper part of the primary winding, same voltage, same magnitude voltage induced in the lower part of primary winding and same voltage is induced in the secondary winding also. So this is the transformer. Now here we see one more thing. Here we connect the load in parallel with the secondary winding of transformer. So we know that when we connect two components in parallel, the voltage across the component is equal. So this is the load side. Now a question come in mind, why this circuit is called parallel inverter? So the answer is, here we use an important component that is called commutating component. Here capacitor is work like a commutating component and this commutating component is connect in parallel with the load via this transformer. That is why it is called parallel inverter. Again I will tell you, here we use a main component that is capacitor. Here capacitor is work like a commutating component. What do you mean by commutating component? The component which is responsible to commutate or turn off thyristor T1 or T2, that component is called commutating component. And this commutating component is connect in parallel with the load via transformer. That is why this circuit is called parallel inverter. So here capacitor is the main commutating component. Now again come at the source side. Here we see, here we connect inductor in series with source. When we connect inductor in series with source, this inductor is work like a constant current source, and this will provide a constant current to the inverter circuit. So this is the whole description of parallel inverter. One point we have to consider that if the polarity across capacitor is upper plate is positive and lower plate is negative, we consider that the voltage across capacitor is positive. If the upper plate of capacitor is having negative potential and the lower plate of capacitor having positive potential, we consider that capacitor is charged with negative voltage. This is first consideration. Now the second point is, if current flow across the capacitor in this direction, IC current, this is the reference direction of current flow across the capacitor, and this current is considered to be positive. If current flow across the capacitor in this direction, in opposite direction, it means the capacitor current flow in this direction, we consider that this is the negative current. So these 2 points we have to consider. Now this is the whole description of the parallel inverter circuit. Now I will explain you the working of this inverter circuit, and simultaneously we draw the waveform also. So here this is the circuit diagram which I have. So this is the this is the circuit diagram of parallel inverter which I have already explained you. Here we use two thyristor T1 or T2, which is like a power semiconductor switching device. Here we use a DC power supply at the input side of the inverter. Here we use inductor in series with DC power supply. So this will make a constant current source for inverter circuit. Here we also use a transformer. This transformer is a center taped transformer. Now come at the load side. Here we use a load in parallel with the secondary winding of transformer. So the voltage across these two components is equal. Now here we also use a commutating component, that is capacitor, in parallel with the primary winding of transformer. It means the voltage across these two components is also equal. So this is the brief description of parallel inverter circuit. Now to understand the operation of the parallel inverter, here I will divide the whole operation into 3 modes. So one by one I will explain all the modes, and simultaneously we draw the waveform. So in case of first mode, the time interval of first mode is 0 to T1. In this time interval, T1 is turned on and T2 get turned off. So how we turn on T1? Here we see this is T1 thyristor, and T1 thyristor is in forward blocking mode. So to turn on T1 thyristor, here we provide a gate triggering pulse at the time interval 0 to T1. At this time instant, 0 time instant, here we provide a gate triggering pulse to thyristor T1, and T1 start conducting. When T1 is turned on, it is behave like a short circuit. When T1 is behave like a short circuit, the current follow the path. We know that current always flow from positive terminal toward negative terminal. So the supply current flow from supply voltage Vs, inductor, T1 thyristor, upper part of primary winding AO, and follow this path and back to the supply voltage. It means current follow this loop. When current follow this loop, we know that the direction of current across the primary winding is A toward B. So this time terminal A is positive with respect to B. So if A is positive, O is negative, and if B is negative, then here this terminal is positive. So due to the current flow across the coil, the voltage induced across the coil is at the upper part Vs supply voltage. Same magnitude or same polarity voltage is induced at the lower half of the primary winding, that is Vs. So Vs voltage at the both side of the primary winding, and same voltage induced in the secondary side of the transformer, that is equals to Vs. And we know that load is connected in parallel with the secondary winding of the transformer. So the output voltage is also equal to Vs. This time we know that capacitor is connected in parallel with the primary winding. So capacitor is charged with voltage plus 2 Vs, and the polarity across the capacitor is upper plate is positive and lower plate is negative, because the polarity of primary winding is A is positive with respect to B. So the overall voltage come across the capacitor side. Vs plus Vs, 2 Vs. So capacitor charged with 2 Vs supply voltage. Okay, now we draw the waveform. So at this time interval 0 to T1, this is the mode 1 time interval. At time instant 0, here we provide a gate triggering pulse to thyristor T1 and T1 get turned on. When T1 get turned on, current flow in this direction and capacitor is charged with 2 Vs supply voltage. So here we draw the capacitor voltage waveform first, Vc. So the voltage across capacitor is 2 Vs. The magnitude is plus 2 Vs. Now we draw the capacitor current waveform. So here we see when T1 is turned on, the current flow in this direction, supply voltage, inductor T1 and the upper half of the primary winding. There is no current flow across the capacitor this time. So capacitor current is 0. So here we draw capacitor current is 0 this time. Okay. Now we draw the waveform of output voltage. So output voltage this time is Vs is equal to Vs. So here we draw the waveform of output voltage. The magnitude of output voltage is Vs. Now in case of parallel inverter, one point should be remembered. The output voltage waveform is just similar to the capacitor voltage waveform. The only difference is the magnitude. The output voltage magnitude is just half as compared to capacitor voltage. And the overall waveform you see later is just similar to the capacitor voltage. So when you remember this point, this will help you in your exam. When you draw the waveform, you know that the output voltage waveform is just similar to the capacitor voltage waveform. So you easily draw the waveform of output voltage and capacitor voltage. Okay. So this point you should be remember. So this is the mode 1 operation. Now we go forward in mode 2 operation. In case of mode 2, the time interval of mode 2 is T1 to T2. In this time interval, T1 get turned off and we turn on T2 thyristor. So how we turn on T2 thyristor, how T1 thyristor get turned off, I explain here. So here we see in the waveform, this is the time interval of mode 2, T1 to T2. In this time interval, at time instant T1, in this point, here we apply a gate triggering pulse to thyristor T2. When we apply gate triggering pulse to thyristor T2, T2 thyristor is turned on and behave like a short circuit. At this time, it means at time instant T1, when we apply gate triggering pulse to T2 thyristor, at this time, the polarity across capacitor is upper plate is positive and lower plate is negative, and voltage across capacitor is 2 Vs. Due to this polarity of capacitor, the T1 thyristor, this terminal is connect from the higher potential of the capacitor, and T1 thyristor, this terminal is connect from the lower potential of the lower plate of capacitor. So that will make thyristor anode is negative with respect to cathode, and we know that when anode is negative with respect to cathode in case of thyristor, thyristor will be turned off and it will behave like a open switch. So here, due to this capacitor polarity at time instant T1, this capacitor will turn off the thyristor T1, and this thyristor is work like a open switch, so there is no current flow across the thyristor T1. So how supply current will flow? Supply current flow from Vs supply voltage, inductor, T2 thyristor, lower part of primary winding of transformer in this direction B2O, and the current follow this path. It means in mode 2, current flow in this direction via T2 thyristor and the lower half of the primary winding. When current flow in this direction in the primary winding of transformer, this means that B is positive this time with respect to A. When B is positive, O, this terminal is negative, and when A is negative, this point is positive. So due to this current flow, a minus Vs supply voltage induced across the primary winding of the transformer. At the lower half minus Vs voltage and upper half minus Vs voltage. And minus Vs voltage is also induced at the secondary winding also. So this voltage is equal to the output voltage. So this time output voltage is minus Vs. Now you think that when minus Vs voltage induced at the primary winding, so capacitor is charged with minus 2 Vs voltage. No, because we know that the property of capacitor cannot allow instantaneous change in voltage, because previously capacitor having this polarity. So meanwhile, when current flow in this direction, meanwhile capacitor discharged its charge in this direction. So this is the direction of capacitor current, and capacitor release its energy. We know that capacitor having two property. One property is capacitor cannot allow the sudden change in voltage, and second property is when capacitor is fully charged, after some time it will discharge its voltage or it will discharge its energy. So when current flow from T2 and this direction, meanwhile capacitor discharge in this direction. So due to this, we draw the waveform at time instant T1. Here we turn on T2 thyristor with the help of this gate current. When T2 thyristor will turn on, capacitor discharge current. Here we see capacitor discharged in this direction. So slowly capacitor will discharge, and at this point capacitor complete discharge and the voltage across capacitor is 0. It will take very short time to discharge its voltage. After that, when current flow in the lower winding of the transformer, capacitor again start charging with some voltage that is equal to minus 2 Vs, because in this time minus Vs voltage is induced in the lower half of primary winding and minus Vs voltage induced in the upper half of primary winding. So the total voltage is minus Vs plus minus Vs minus 2 Vs. And the polarity across the capacitor this time is lower plate is positive and upper plate is negative this time. So now we draw the waveform. Here capacitor lost its energy and the voltage across capacitor is 0. Now again, due to this current flow, capacitor again slowly charge, and at a very small time capacitor charge with maximum voltage, that is minus 2 Vs, because we know that the curve is due to the property of capacitor. Capacitor cannot allow sudden change in voltage. So slowly capacitor will charge. And this point the maximum voltage across the capacitor is minus 2 Vs. This time the polarity across capacitor is upper plate negative and lower plate positive. Now we draw the waveform of capacitor current. So at the time instant T1, when capacitor start discharging in this direction, the current across capacitor is maximum. So here the current across capacitor is maximum in reverse direction, because this is the reverse direction of current flow. Now slowly when capacitor is discharging its energy, the current across the capacitor is also decreasing, and at this point the capacitor current is 0, because slowly capacitor will discharge its energy. Now the output voltage waveform. In this case the output voltage is T1 time interval is plus Vs, and we know that when current flow in this direction B2A in the primary winding, the output voltage across load side is minus Vs. And we know that, as I have already told, the waveform of capacitor voltage and output voltage is just similar. Only the change in the magnitude, the output voltage magnitude is just half to the capacitor voltage. Now what happened after this point? After this point capacitor is charged with 2 Vs minus 2 Vs voltage. So when we not change any condition, it means when we not turn on any other thyristor, this time T2 is already turned on, T1 is turned off, the same situation in mode 2, we not change any condition. So the property of capacitor is a charge storing device. It will store charge for some time. So Due to this property of capacitor, capacitor will store charge. It means the same voltage across the capacitor will maintain at this time interval, that is minus 2 Vs. Now what about the capacitor current? Here we see at this time instant the capacitor current will reduce and attain its zero value. So here capacitor current is not changed because there is no condition change. Here we not turn on T1 thyristor, we not turn off T2 thyristor. So there is no change in condition. Current is also zero across the capacitor. Because here we see capacitor is charged because of this polarity of primary winding of transformer. So there is no flow of current across capacitor. Now what about output voltage? At this time instant the output voltage across load is minus Vs. So again output voltage is also constant and maintain minus Vs supply voltage. So this is the waveform of mode 2. Now we move in mode 3. In case of mode 3, the time instant of mode 3 is T2 to T3. In this time interval, we turn on thyristor T1 and T2 get turned off. How T2 get turned off? How we turn on T1 thyristor? So here we see in the waveform, in this time interval, we provide a gate triggering pulse to thyristor T1. So when we provide gate pulse to thyristor T1, T1 get turned on and behave like a short circuit. This time at instant T2, the voltage across the capacitor is minus 2 Vs. Here we see at this time instant when we apply gate triggering pulse to thyristor 2, the voltage across capacitor is minus 2 Vs. And the polarity across the capacitor is upper plate is negative and lower is positive. So when T1 gets short circuit or turn on, the higher potential of the capacitor is connect from this terminal of T2 thyristor. And the lower potential of capacitor is connected from this terminal of T2 thyristor. Due to this, the anode of the T2 thyristor is negative with respect to cathode. And we know that when anode of thyristor is negative with respect to cathode, thyristor get turned off and is behave like a open switch. Due to open switch, there is no current flow in this path. So the path of the current is, in this case, current flow from supply voltage through inductor T1 thyristor, upper part of primary winding from A to O and follow this direction back to the supply voltage. It means current follow this path. Supply voltage, inductor, T1 thyristor, upper part of primary winding and back to the supply voltage. When current flow in this direction, the polarity across the primary winding of transformer is, the direction of current is this. So A is positive with respect to B. And the voltage induced in the primary winding is, the voltage across the upper half of primary winding is Vs and the voltage across lower half of primary winding is also Vs, and the same voltage Vs is induced across the secondary winding of transformer. So the output voltage is equals to supply voltage Vs. But here we see the capacitor is connected in parallel with the primary winding of transformer. So you think that the capacitor is charged with plus 2 Vs voltage. But we know that capacitor cannot change voltage instantaneously. So when current flow in this direction, meanwhile capacitor releases energy in this direction. So the flow of current across capacitor in this direction. We draw the waveform of capacitor voltage. Here capacitor release its energy and at very small time interval capacitor releases its whole energy and the voltage across capacitor is 0. When capacitor releases its energy, after that capacitor will start charging with this voltage Vs plus 2 Vs. Now this time polarity across capacitor, this terminal become positive and this terminal become negative. Now again I will explain you at the starting of mode 3. It means at time instant T2. Current flow in this direction via thyristor T1, upper part of the primary winding, and the voltage induced across the primary winding is Vs at the upper part and Vs supply voltage at the lower half of primary winding. So the total voltage is Vs plus Vs. Same Vs voltage induced across the secondary winding of the transformer. So the load voltage is also equal to supply voltage Vs. But we know that at this time instant, capacitor should be charged from plus 2 Vs supply voltage. But due to the property of capacitor, this will not happen. Because capacitor having property, capacitor cannot change voltage instantaneously. And the second property of capacitor is, once capacitor is fully charged, after that capacitor will release its energy. So this time, at time t2 instant, this time instant, capacitor is fully charged with minus 2 Vs voltage. So again capacitor will release its energy. So capacitor having this polarity at time instant t2. So this time capacitor release its energy in this direction. Same time current will flow in this direction. So capacitor when release its energy, here we see this slowly capacitor will release its energy, and at this point capacitor voltage is 0. When capacitor voltage is 0, capacitor again charge with this polarity of voltage. It means when current flow in this direction, Vs plus Vs supply voltage induced in the primary winding. So the total voltage of primary winding is 2 Vs plus 2 Vs. So capacitor slowly charged with plus 2 Vs voltage. So here we draw capacitor slowly charged with plus 2 Vs voltage, or at very small time interval, capacitor reach its maximum 2 Vs voltage due to the property of capacitor. At this time instant, current across capacitor is, when capacitor discharge its energy, the current across capacitor is maximum, and slowly capacitor reduce its current, and slowly when capacitor discharge, the current across capacitor is also reduces and becomes 0 at this point. Now output voltage waveform. So at this time instant, output voltage across load is minus Vs, and when capacitor voltage is 2 Vs, the output voltage is plus Vs. So the same waveform is followed by the output voltage, and output voltage become positive, that is equals to the supply voltage Vs. So in this way we draw the waveform of parallel inverter, and this is the whole description of parallel inverter circuit. So hope you like the video. If you understand the whole working of the parallel inverter, please mention in comment box, and please stay continue, keep watching and keep sharing my videos with your friends. If you want to notes, please visit my website. The link of the website I will give in my description box, that is www.quick-learn.in. And if you are preparing for any competitive exam, in my website I have already uploaded some MCQ question series and some mock test that will help you in your competitive examinations. Stay connected, keep watching and keep sharing my video. Bye bye.